Hey folks, Professor Gray here, ready to talk to you about finding mean confidence intervals if sigma, that's the population standard deviation, is unknown. Well, to find a confidence interval for mu using a normal distribution, we need to know sigma, that's the population standard deviation. Well, how likely do you think it is to actually know the population parameter, population standard deviation, in real life research? Well, it's very unlikely, as a matter of fact. If we already knew that much about the population, then maybe we wouldn't be doing research about it. After all, that would be kind of the point. So it's more likely that you don't really know sigma. But when we don't know sigma, instead of using a normal distribution, there's something else we can do. We can use the student's t distribution. And instead of using the population standard deviation, we'll use the next best thing, the sample standard deviation, that's S. Here's a little bit about the student's t distribution. Well, it's bell-shaped, just like the normal distribution, unimodal, just like the normal distribution, and symmetric about the mean, again, just like the normal distribution. It also involves something called degrees of freedom. We'll denote that with df, that's degrees of freedom. And the degrees of freedom is a combinatorial idea that comes into play with some theory that's beyond the scope of this course. But suffice it to say, the degrees of freedom is going to be the sample size minus 1. Also, as the degrees of freedom increase, or as the sample size increases, the t distribution becomes a standard normal distribution. So the t distribution, if n gets big enough, will become the standard normal distribution. Well, critical values, t sub alpha over 2, separate the area alpha over 2 in the right tail of the t distribution, just like z sub alpha over 2 does for the right tail of a normal distribution. Same idea, we're just in a different distribution. So let's find t sub alpha over 2 for the given values of alpha and n. For number 17, alpha, that's the area in both tails combined, or in one tail total, is 0.10, and the sample size is 6. This means, if I were to sketch this out, half of alpha is in each tail, so 0.05 is in the right tail, 0.05 is in the left tail. Since the sample size is 6, that means the degrees of freedom, which is n minus 1, is going to be 5. Now, if I go to my tables that I use for this course, here they are. Table A3 has a t distribution critical t values chart. So I find the degrees of freedom, again that was 5, and I'll match that up with the area in one tail or in two tails. Well, the area in both tails combined was 0.10. So that would be the next to last column going left to right. Area in two tails is 0.10. Now the area in just one tail is 0.05. Again, that gets me to the next to last column going left to right. So I'll match up the column to my row, and I get the answer of 2.015. So the t-score, not a z-score this time, but a t-score, on the right-hand side is about 2.015. That's T sub alpha over 2. And now the tables have rounded these numbers. That's why I'm using an approximately equals 2. But that's my critical T value. Question number 18 asks, well, what if alpha is 0.05 and the sample size is 10? Let's do this one. For number 18, if I were to sketch that, I have my T distribution. And since there's a total of 0.05 area in both tails combined, I'm going to have half of that in each tail, 0.025. And because my sample size is 10, that means that the degrees of freedom are 10 minus 1, which is 9. Again, I'm looking for the t-score, t sub alpha over 2. On the right-hand side of this distribution. Alright, if I go back to the table, the degrees of freedom are 9 this time. And the total area in both tails, so area in two tails, would be 0.05. That's the middle column. Area in one tail was 0.025. It also gives me the middle column, so it doesn't really matter which one of these you choose to go by in these cases. I'll line that column up with the row, and I get 2.262. So that's my answer. The critical value is about 2.262. That's my critical T value. Let's do another. Number 19 says, what if alpha is 0.01 and the sample size is 12? Well, let's sketch this one as well. Number 19. Alpha is 0.01, so 0.005 would be in each tail, since confidence intervals are two-tailed. I'm looking for the t-score on the right-hand side. My sample size is 12 in this case. So the degrees of freedom, df for short, will be 11. Again, sample size minus 1. So I'll go over to my chart. 11 is the degrees of freedom. And I had 0.01 as the area in two tails. That would be the first column on the left. If I want to think about it in terms of how much is in one tail alone, then I again get the first column. I line up those two columns, or excuse me, the column and the row, and I get 3.106. That's my answer. So now I've found another critical value for use in a t-distribution confidence interval. We will use this critical value in order to help us find confidence intervals when sigma is unknown, which I'll cover both with minimal calculator help and by using the calculator's built-in statistics capabilities in another video.